dear learners. I, Akanksha Singh Gautam, lecturer in Electronics and Telecommunication Department at Government Girls Polytechnic, Raipur, welcome you all to explore communication systems. Can you imagine a world without phone, internet and television? It's hard, right? Many areas of modern life are only possible because we have robust communication systems that allows us to communicate with each other. We share information and use services. It can be sending a message over text, streaming the video, or calling your friend. These are an imperative part of our day-to-day lives. By the end of this lecture, you will have a clear understanding of several key aspects of communication systems. So let's start. What is a communication system? The communication system is a system which describes the exchange of information between 2 points. Communication is the basic need in every walk of life, and we share information with one another through this system while covering various distances. Communication systems are used whenever you perform something where that thing involves the exchange of information between two parties. It can be, like I already told, calling somebody over phone or browsing through internet or watching television. All functions have some communication system involved which is responsible for collecting data from source. Source can be communication sender. It is in desired encoded form and sending to the destination end, which will be communication receiver. Now, we will dive into its component, variations and examples of what such systems might look like in everyday life to get an idea how they work. So let's start with components of communication system. First, we will see a transmitter. The function of a transmitter is to convert information into a signal suitable for transmission. This process can involve encoding the data and modulating the signal. The real life example could be sending a voice message. When you send a voice message on your smartphone, your phone's microphone captures the voice. The device converts its analog audio signal into a digital signal through a process called analog to digital conversion. This digital signal is then modulated and prepared for transmission over the cellular network. The another example could be medium or channel. Its function is the medium is the path through which the signal travels from the transmitter to the receiver. This can be a physical medium such as cables, you might have seen cables as well, or a wireless medium. Now, as everybody uses a Wi-Fi. Its real life example could be a video call. When you make a video call using an application like Zoom or FaceTime, your data is transmitted through various mediums. Initially, it may travel wirelessly from your device to a Wi-Fi router. From there, it could move through fiber optics cable across the internet and potentially via satellite links before reaching the recipient device. The last component is the receiver. Now, let's see what a receiver do. The receiver captures the transmitted signal and converts it back into a form that can be understood by the recipient. So, its example could be receiving a voice message. When the recipient plays your voice message, their phone receives the digital signal, decodes it and converts it back into an analog audio signal through digital to analog conversion. The phone speaker then plays the sound for the recipient to listen. Now we will see what are the different types of communication systems. The first one could be analog communication. It uses continuous signal that varies in amplitude or frequency. Its example could be AM or FM radio. Traditional radios broadcast use analog signals when you tune your radio to a station. The station transmitter sends out continuous radio waves. Your radio receiver picks up these waves, demodulates them and converts them into sound. The another type is digital communication system. It uses discrete signal, typically represented by binary codes. Binary codes will be 0 or 1. Its example could be sending a text message. When you send a text message, your phone converts the text into binary data. This data is transmitted over cellular network. The recipient phone receives the data and decodes it and displays the message. Now, after type, we will see modes of communication. It could be simplex. Communication in only one direction is called simplex. Its example could be television broadcasting. When you watch television, the signal is transmitted from the television station to your television. You receive the signal but do not send any information back to station, right? The another is half duplex. Communication in both the direction but not simultaneously is called half duplex. Its example could be walkie-talkie. When you use a walkie-talkie, you press a button to talk and the another person listens. To respond, they press their button while you listen. Communication happens in both the direction, but only one person can speak at a time. Now, full duplex communication. Communication in both direction, but it will be simultaneously. Its real life example could be a phone call. During phone call, both parties can speak and listen at the same time. This allows for natural two-way conversation without any waiting time. Now, we will dive into its real life application of communication system. For the first, we will see telecommunication systems. So, the first example for it could be mobile networks. When you make a phone call or use mobile data, your device connects to the nearest cellular tower. This tower communicates with another tower and network infrastructure to route your call or data to its destination. Mobile networks enable communication from almost anywhere, whether you are in a city or a remote area. The second example could be broadcasting system, for which we will take example of a television. When you watch a television show, the broadcasters send out video and audio signals via satellites or cable networks. Your television receiver decodes these signals and displays the content. Digital broadcasting ensures high quality video and sound, providing a seamless viewing experience. The third telecommunication example could be data communication systems. Its example is internet. When you send an email or browse a website, your computer sends data packets over the internet. These packets travel through routers, switches, and various network paths to reach the destination server. The server processes the request and sends the required data back to your computer, which reassembles the packet to display the information. We will now see what is signal processing. Noise cancelling headphones are the great example of advanced signal processing in action. Now we will see a detailed explanation of how they work to cancel out unwanted ambient noise. First, capturing the ambient sound. Noise cancelling headphones are equipped with external microphones that continuously captures sounds from the surrounding environment. These microphones pick up ambient noise such as the hum of an airplane engine, the chatter in a coffee shop, or traffic sound. What is a microphone then? Tiny devices embedded in the headphones that detects external sound and converts them into electrical signals. The processing the signal once the ambient noise is captured by the microphone. The headphones are built in digital signal processing (DSP) to analyze these sounds. The DSP is a specialized computer chip designed to process audio signals quickly and efficiently. Now, what is DSP? The digital signal processing analyzes the captured noise and calculates how to counteract it. The DSP generates an anti-noise signal, which is an inverted version of the captured ambient noise. This anti-noise signal has the same amplitude but an opposite phase, which is 180-degree out of phase compared to the original noise. What is an anti-noise signal? A sound wave that is in the mirror image of the captured noise wave, effectively cancelling it out. Generating the opposite sound wave, the anti-noise signal is fed into the headphone speakers along with the audio you want to listen to. It could be music or podcast, etc. When the anti-noise sound wave meets the incoming ambient noise wave, they interfere with each other. What is a destructive interference then? When two sound waves of equal amplitude and opposite phase meet, they cancel each other out. By playing the anti-noise signal through the speakers, the headphones create destructive interference with the ambient noise, effectively reducing or eliminating the unwanted sound. Listening experience. As a result of this process, the unwanted ambient noise is significantly reduced, allowing the user to hear the desired audio content more clearly and with less distraction. The last part will be speaker. It emits both the anti-noise signal and audio content the user wants to listen. To promote enhanced listening, the user experiences clearer audio without being disturbed by external noise. Its real-life application could be ambient noise capture. The headphones microphone continuously pick up surrounding noise like airplane engine or office chatter. For signal processing, the DSP calculates an anti-noise signal that is exact opposite of the captured noise. For sound wave generation, the anti-noise signal is played through the headphone speaker, creating destructive interference with the ambient noise. For noise cancellation, the external noise is cancelled out, leaving the user with a quieter environment and clearer audio from their music or podcast. Now we will see what is its importance and its impact. Noise cancelling headphones enhance the listening experience in noisy environment by allowing users to focus on their audio content without any distraction. They are particularly useful for travelers, commuters, and anyone needing a quiet environment in a noisy setting. For error correction and detection, its example could be QR. What is a QR? It is quick response codes are two-dimensional barcodes that stores data in a pattern of black and white squares. They are widely used for various purposes such as product tracking, marketing, and mobile payments. Here's how QR codes use error correction to ensure data accuracy, even when the code is damaged. First, we will see a QR code structure. A QR code consists of modules arranged in a square grid. Each module can either be black or white. The black represents 1 and white represents 0, forming a binary pattern that encodes data. QR codes can store different type of information, such as it could be URLs, text, contact information, app link, and many more. Now we will see how data is encoded in QR. Information is encoded into the QR codes pattern of black and white modules. For error correction capabilities, we will see to enhance the reliability, QR codes incorporate error correction techniques and add redundancy to encoded data. This redundancy allows the QR code to withstand damage or distortion without losing the ability to be scanned and decoded accurately. For error correction levels, QR codes can be generated with different error correction levels. It could be low, medium, quartile, and high. Each level provides a different degree of error correction capabilities, with higher level offering more redundancy. For that, we will see a code which is called as Reed-Solomon error correction QR codes. It typically uses Reed-Solomon error correction, a well-known algorithm that adds extra error correction code words to be encoded data. These code words are distributed throughout the QR codes matrix and can correct errors caused by damage, smudges, or other forms of interference. For error correction code, additional data added to the QR code to detect the correct errors. For data recovery process, when a QR code is scanned, the decoding software or app uses algorithms to analyze the pattern of modules and reconstruct the original data. If part of the QR code is damaged or unreadable due to poor printing quality or environmental factors, the error correction code helps in error detection and error correction. Error detection is the identifying which part of the QR code is damaged or corrupted. For error correction, using the redundant information to correct errors and recover the original data. Let's see a real life example. For example, when a user scans a QR code using a smartphone camera or QR code reader app, the decoding software decodes and detects errors or discrepancies in the QR code's pattern. The software uses the Reed-Solomon error correction to reconstruct the original data. even if part of the code is damaged. For data retrieval, the decoded information such as a URL or contact details is presented to the user for further action. The importance and impact of error correction in QR codes ensures robustness and reliability in data transmission and retrieval. It allows QR codes to maintain usability even when they are subjected to wear and tear, printing imperfections or environmental factors. This capability is crucial for applications where data integrity and accuracy are paramount, such as inventory management, ticketing system, and mobile payments. For communication protocols, when you access a website through your web browser, the communication between your device and the web server involves the use of HTTP. What is HTTP? HTTP stands for Hypertext Transfer Protocol, or its secure variant HTTPS, Hypertext Transfer Protocol Secure. Here's how this protocol works to request and receive web pages. For Hypertext Transfer Protocol, HTTP is the foundation of data communication on the World Wide Web. It defines how messages are formatted and transmitted, and how web servers and browsers should respond to various commands. For request response model, your web browser initiates communication by sending an HTTP request to a web server. What is an HTTP request? The request typically includes the URL of the source page you want to access, along with other optional parameters such as cookies or authentication credentials. We will now see what is the server response. The web browser server processes the request and responds with HTTP response. This response includes the requested web page content, along with the HTTP headers that provide additional information about the server, content type, caching instructions, etc. We will now see what is Hypertext Transfer Protocol Secure, HTTPS. It is the secure version of HTTP, as the name suggests, that uses encryption to protect the integrity and confidentiality of the data exchange between the client, which can be your browser and the server. For encryption, HTTPS encrypts the data using SSL or TLS, Secure Socket Layer or Transport Layer security protocols. This ensures that sensitive information such as login credential, payment details, and personal data remains private and secure during the transmission. For authentication, HTTPS also authenticates the identity of the website to ensure that you are connecting to the intended server and not a malicious imposters. For secure connection, once a secure connection is established, the HTTP request and responses the encrypted and decrypted data respectively, protecting the data from eavesdropping and tampering. Now we will see how we use this in real life application. We'll start from when you type a website URL. It could be any URL in your web browser address. The browser sends an HTTP or HTTPS request to the server hosting the website. The web browser receives the request processes it and prepares a response. For response transmission, HTTP responses, the server sends back an HTTP response containing the requested web page. The server sends back an encrypted HTTPS response, ensuring secure transmission of sensitive data. Now, we will see the fourth very important example is rendering. Your web browser receives the response and renders the web page content for you to view and interact with. Its importance and impact. HTTP and HTTPS protocols are fundamental to web browsing, enabling seamless and secure communication between clients and the server. They ensure that web pages are delivered efficiently and sensitive information is protected from unauthorized access and interceptions. The widespread adoption of HTTPS has become crucial for maintaining trust and security on the internet, particularly for e-commerce, online banking, and other sensitive transactions. Now, we will see its applications in wireless communication technology. We often call it Wi-Fi technology, which enables multiple devices within a home or environment to connect to the internet wirelessly, offering convenience, mobility, and flexibility. Here's a detailed explanation of how Wi-Fi works and its benefits. First is wireless connectivity. Wi-Fi operates by transmitting data over radio waves within a specified range, typically around 100 feet indoors. This range can vary depending on factors like obstacles, it could be wall or furniture, and the type of Wi-Fi routers or access point used. For wireless access points, Wi-Fi routers or access points creates a local area network that allows devices to connect wirelessly. For radio frequency, Wi-Fi uses radio frequencies in the range of 2.4 GHz to 5 GHz. This band to transmit data between devices and the internet. The device connectivity devices equipped with the Wi-Fi capabilities such as smartphone, laptops, tablets, smart TVs, and IoT devices can connect to a Wi-Fi network. Each device communicates with the Wi-Fi router or access point using a unique identifier called as MAC address. MAC stands for Media Access Control. Okay, now let's see another example which is called as SSID. Wi-Fi networks are identified by an SSID. SSID stands for Service Set Identifier. Which user selects or configures on their router. It acts as the network's name. For authentication, devices must authenticate with the Wi-Fi network by entering a password or through other authentication method. When internet access once connected, device can access the internet through the Wi-Fi network. The Wi-Fi router acts as a gateway forwarding data packets between devices on the local network and the Internet Service Provider (ISP). For the data transmission, Wi-Fi enables high-speed data transmission, allowing devices to stream videos, browse websites, download files, and communicate online. For bandwidth management, routers manage bandwidth allocation to ensure optimal performance for all connected devices preventing congestion and slowdowns. Its convenience and mobility, Wi-Fi provides several advantages. For flexibility, users can move freely within the Wi-Fi coverage area without being physically cable, enhancing mobility and convenience. It provides multiple connection. A single Wi-Fi router can support multiple devices simultaneously, allowing household or offices to connect numerous devices to the internet without additional wiring. For expandability, Wi-Fi networks can be expanded by adding additional access points or which mesh Wi-Fi system to extend coverage to larger areas or dead zones. Let's see a real-life example of home network. Let's see a family uses Wi-Fi to connect their smartphone, tablets, laptops and smart TV to the internet for streaming movies, browsing social media or working from home. Also, for IoT devices, smart home devices like thermostat, security camera and voice assistant connects to the Wi-Fi network for remote monitoring and control. As per for the public Wi-Fi, which is used by cafes, airports, hotels, offers Wi-Fi access to their customer, providing internet connectivity for visitors and guests. Let's see their importance and impact. Wi-Fi technology has revolutionized how people access and use the internet, enabling seamless connectivity across various devices and locations. It supports modern lifestyle, facilitates remote work and education, and enhances internet experiences. Wi-Fi's convenience and mobility make it indispensable at homes, businesses, public space and beyond, shaping the digital connectivity landscape worldwide. So, as we continue our exploration of this field, we will deal deeper into signal processing, modulation techniques and advanced communication protocols. Understanding these concepts will not only enrich your knowledge but also empower us to appreciate the complexity innovations driving modern communication technologies. So, thank you all. This was Akanksha Singh Gautam and I hope to see you in our next lecture, which will be on analog signal representation. Thank you very much.